Once again, we are back in quadratic equations. I am answering questions from HSLC 2015 of the Assam board. This is question number 23 in the question paper. Its mark weightage is 3 marks. And if you would look at exercise 4.2 number 4, this question is in text, is a exercise question of the NCERT book. Now here it says find two consecutive positive integers, the sum of whose squares is 365. The meaning of the word consecutive means one after the other. Like in when you count numbers, you count 1, 2, 3, and the consecutive numbers following after 3 would be 4 and 5. So when they say to you find two consecutive positive integers, it means you have to find two positive integers which are one after the other. And since we do not know what are these integers, we begin the solution by stating, let the integers be x and x plus 1. Why? Because x is smaller than x plus 1 because you add 1 more. The difference between two integers is 1 when they are consecutive. So here we construct the equation. Constructing the equation, you would need to have the statement of equality in the middle that shows that this something here is equal to 365. And they say the sum of whose squares is 365. So it means that if you square x squared plus then the other number x plus 1 whole thing square, you will get 365. And you need to apply the special product of x plus y whole thing square there. So it would become x squared plus 2xy plus y squared, which means taking 1 as y when you use the special product, is equal to 365. You're almost getting a quadratic equation here. So this becomes 2x squared plus 2x plus 1 is equal to 365. Now you can never get the true value of the statement of equality when you do not put 0 this side, so there should be a transposition like this. So you create the quadratic equation by putting it further, 2x squared plus 2x plus 1 minus 365 is equal to 0. Since there is a negative and a positive here, you need to cancel that again. 2x squared plus 2x minus 364 will be equal to 0. You now have a quadratic equation, but then if you watch this equation, it all has even numbers. 2 is an even number, another 2 is an even number, 364 is even. And you would notice that there is a common factor 2 with all the terms in this trinomial quadratic equation. So we will divide the whole equation by 2. So what do? You write here x squared plus x minus 2 1s are 2, 2 8s are 16, 2 2s are 4 is equal to 0. And right here, dividing left hand side and right hand side by 2. Now you have an equation which is up to your choice of how to solve this. But then let's go ahead and do it by factorization method. And here let's split the middle term x. Now to split the middle term x, this is the coefficient of x here is 1 because there is no number there. And how do we split this so that when we add or subtract the factors, we get a positive 1? As usual, I would say draw your working column and prime factorize 182. 2 9s are 18, 2 1s are 2. Then here you have 7 1s are 7, 7 3s are 21. Now immediately you would see that if you multiply 2 and 7, you will get 14, and then you have 13. So which means that 182 is 14 into 13. And here you have a 1, so one of them would be a negative, one would be a positive, so that when you cancel them, you get 1. 14 plus of minus 13 is equal to 1. So having done that, we now can split x squared, and we write plus 14x minus 13x minus 182 is equal to 0. Then you look at x and 14. X squared is equal to x into x, and 14x is equal to x into 14. You would see this is common for both, so that comes out, and what stays in is the non-common, which is x plus 14. And the clue, since when you multiply 14 and 13, you get 182, and you need a 14 inside the bracket, so you obviously would know that 13 is here, and 182 also has 13 as a factor. So we put here minus 13, and then we put x there, and multiplying the signs, minus into plus would give you a minus, so here you would put 14 is equal to 0. Now you can get x minus 13 and take the common one, the common binomials which are the same as only ones, you get 0. And then you can say, therefore, the roots of the equation are the values of x. Either x minus 13 is equal to 0, which imply that x is equal to 13, or x plus 14 is equal to 0, which imply x is equal to minus 14. Yes. Since we need positive integers, then you would say, therefore, the numbers are x is equal to 13, or x plus 1 is equal to 13 plus 1, which is equal to 14. And your answer is x is equal to 13, x is equal to 14. You do not take the the value that you got as root as x is equal to minus 14, because they need positive integers. So you take 13, and the other consecutive number is x plus 1, which is equal to 13 plus 1, which is equal to 14. Thank you so much for your time. Please do continue to like my videos and comment in the comment section, and also share the videos so that others can benefit from it. Thank you so much.